Okay, um, so in this lesson, folks, our goal is to be able to identify reaction and reaction pairs. If you don't know what that is, we'll learn by the end of the lesson. Agenda for today, you should finish or make corrections to the Newton's second law lab. Um, so if you haven't turned that in, you should try and do that first. If you have turned it in, you should check to see if I made any comments on your submission. Um, and then make corrections based on those comments. You're going to take notes on Newton's third law. That's supposed to say, hold on one second here. Sorry about that. Take notes on Newton's third law. And then you're going to complete the homework problems on Newton's third law. Okay, so Newton's first law of motion tells us that forces cause objects to accelerate, right? So you can't make an object accelerate without a force. If you don't have forces, objects just keep doing whatever it is they're doing. So if they're not moving, they're going to continue not moving. If they're moving at a certain speed, then they're going to continue moving at that speed or velocity until we make them accelerate with a force. Okay, Newton's second law tells us that stronger forces cause objects to accelerate more than weaker forces. Also, objects with larger masses don't accelerate as easily as objects with smaller masses. All right, and so then today we're going to learn about Newton's third law. So up to this point, this should all be review. If it's not, you might need to go back and do some of those earlier lessons. But Newton's third law of motion tells us that for every action, there is an equal and opposite reaction. Okay, and so I'm going to say that in a little bit different way on the next slide. Another way to state Newton's third law is like this. If object A exerts a certain amount of force on object B, then object B will exert the same amount of force back on object A, but in the opposite direction. Okay, so let's go through a few examples. I think that'll really help clear up what Newton's third law actually is. We do that with action and reaction pairs. So here we've got a shark swimming through the water. And so the force that's happening here is that the shark's tail pushes against the water. The reaction is that the water pushes back on the shark's tail. Now, Newton's third law just talks about action and reaction pairs. So for every action, there's an equal and opposite reaction. People often get the reaction mixed up with the result, though. So the result is what actually ends up happening to the shark, which is that the shark moves forward through the water. But the reaction is actually just the opposite of what the action is. So the action was that the shark's tail pushes against the water. The reaction is that the water pushes back on the shark's tail, right? The result is that the shark moves forward through the water. So let's go through another example. Hopefully that helps clear up the difference between the reaction and the result. So here we've got the moon, right, next to the Earth. So the action is the moon's gravity pulls on the Earth. Okay. The reaction is just the opposite. So we're just going to switch around the Earth and the moon in this statement. The Earth's gravity pulls on the moon. The result, so what happens, right, as a result of this, is that the moon orbits around the Earth. Okay, let's go through one more example. Action, a hammer pounds on a nail. Reaction, the nail pushes back on the hammer. Result, the nail moves into the piece of wood. Okay. action, reaction, and result. Okay. So here we've got a couple of practice problems. In the first one, I give you the action. You just have to give me the reaction and the result. And then in the next few, you've got to give me the action, the reaction, and the result. And then in number 4, you're just going to come up with your own action-reaction pairs. So think of a situation where you've got a force. Remember, a force, there has to be some sort of push or a pull. So that'll be your action. You'll write in some sort of push or pull. And then for the reaction, you'll give me the opposite, right? The reaction to that action. Let me know if you have any questions, as always.